this is Ms. Ward. I'm going to go over the notes for section 6.5, integration by substitution. So up until this point, when we've been asked to find the antiderivative, every single function that we've done has been what's called a simple function. In other words, it's just a basic function without doing any composite functions. So what we're going to do is first we're going to recognize a pattern to find the indefinite interval. Then we're going to use the change of variables to find the indefinite interval. And then use the general power rule and a variety of variables to evaluate. So it's a long process, but when we look at this, what we're going to do is we have to go back to when we took derivatives. And when we took derivatives, we had the chain rule when we had to find the derivative of a function within a function. So I don't know if you remember that. That was like if I took the derivative of f of g of x, I took the derivative of the outermost function, and then I looked inside that function, I took the derivative of what's inside of that. So when we had something like this, when I had x squared plus 1 raised to the third power, the outermost function was something being raised to the third power, so that I make this 3 times x squared plus 1, decrease that power by 1 with 2, and then I looked inside here, and I found the derivative of inside of here was 2x. I'm going to simplify that. I said my derivative was equal to 6x times x squared plus 1. So now, when I go to take the antiderivative, I've got to remember that I of a composite function, I have to remember that I have that extra piece, which is the derivative of the innermost function. So that's what this is saying. When I go to take the antiderivative of a function, I need to make sure that the derivative of the inside function is also part of what's inside the integration symbol. If it's not, I have to adjust it so it is. So it's a process, but when I start with something small, when I start with an easy one, I'm going to first look for patterns. So when I look at this, then what's being raised as powers is x squared plus 1. Well, if I ask you what the derivative of x squared plus 1 was, you would tell me it's 2x. So I can see that I already have that 2x in here, and I have that dx. So this, as it is right now, is good to find the antiderivative. So the way I did that is I just looked at the pattern and kind of figured out what I needed to have in there. So if we have some of these here, so just to show you, I have 2x minus 1, that's what's being raised to the power. Here's that 2x minus 1. I took the antiderivative, so I took that 7 raised to the 8 divided by 8. That's all what we know how to do. But in order for me to do this, I have to look inside of the innermost function, that 2x minus 1. And I have to find the derivative of what's inside there. And the derivative of 2x minus 1 is just going to be 2. So I would have to put a 2 in here in order for it to work. And we'll go through how we adjust if it's not there in a second. So when I'm looking at the next one, I have 2x to the fifth plus 3. There's that 2x to the fifth plus 3. When I took the antiderivative, I took the 4 raised to the 5 divided by 5. That's all what we know how to do. Now I have to look in here and ask myself, well, what is the derivative of 2x to the fifth plus 3? And that is simply going to be 10x. So one more, and then we're having pause the video and do the rest of the round. So here's x to the third plus x squared, x to the third plus x squared. Those have to match. The antiderivative of something raised to the fifth power is 6 and divided by 6. Looking inside here, I ask myself, well, what is the derivative of x to the third? Well, that would be x squared, and the derivative of x squared would be 2x. So that's what's going to have to go here in order for me to find the antiderivative. So pause the video and find the rest. Hey, if you have any questions with those, just come and see me, and I'll go over them. So now what I'm going to do is I'm going to have this chart, and it's going to go step by step with the step that you should go through to actually find the indefinite integral where I'm going to have to sort of substitute in a different variable for my function. So what I'm going to do is I'm going to use g of x to be my innermost function. So basically that's going to be what is raised to the power. So in this case, what is being raised to the power is going to be that x squared plus 1. So I'm going to say u is equal to x squared plus 1. I don't care what power it's being raised to right now. I just want to identify what my u is. Then it says I'm going to compute the derivative of u in terms of x. So the derivative of u in terms of x, I'm going to so I'm looking up here and I'm asking myself, what is the derivative? X is going to be 2x. Then the next thing says it's going to say solve for du. So if I solve for du, I'm going to multiply both sides by dx. So I'm going to have du is equal to 2x dx. And then it says rewrite the integral in terms of the variable u. So I'm going to go back up here, and I said that u was equal to x squared plus 1. So here's this x squared plus 1 that's being raised to the fourth power. So I'm going to say u to the fourth power, because I'm doing an integral. And then I said du was equal to this 2x dx. So up here, I have 2x dx. So I have the whole thing, no adjustment necessary. So I'm going to say du. So now I've rewritten the integral. I've taken care of everything up there in this integral. Everything is taken care of. Everything's highlighted. Everything has been assigned a value. And now I'm just going to, the next step is going to evaluate the results of the integral in terms of u. So I'm going to raise this 4 to the 5th power, divide by 5, and then I have to remember that I'm going to add a constant. And since I'm like in the working process, I'm not going to worry about any other notation at this point right now. So then what I'm going to do is I'm going to say replace the u by the g of x to obtain an antiderivative in terms of x. So I'm going back up here, and remember u is equal to that x squared plus 1. So I'm going to go down here, and I'm going to say x squared plus 1 raised to the 5th power, put that into the u, divided by 5 plus c. And that is going to be my antiderivative of my f of x.
Mr. Pulpit.
Then it says check the answer. So it says check the answer by going up here and finding the derivative of this. And those are the next two. So in order to do the derivative, I would say 5 times this, taking the derivative of the outermost power. So 5 times this x squared plus 1 over 5, and decrease its power by 1, so that would be 2/4. This c, when I take the derivative, would be 0, so it would just drop off. And then I would find that the derivative equals x squared plus 1 to the 4th power. And that is what I started off with. And you're probably saying, well, we just went into the circle. Well, yes, we did go into the circle, and that was the whole point, is proving that this is how it works. So now, going on to example 3, so I'm going to follow the same steps, but first ask myself, what is being raised to power? So when I look here, this 2x plus 3 is what's being raised to the power. So I'm going to say u is equal to 2x plus 3. Then I'm going to evaluate du dx, which would be 2x. Oh no, I'm sorry, it's just 2. And then I'm going to solve for du. So du is equal to 2 dx. Then I'm going to go back up because now I want to rewrite this integral in terms of just u. So I see that I have u to the 1/2 power, and then this dx, I have dx here, and I have dx here, but I need to have, in order for it to be du, I'm going to say that this dx has a 1/2 du. So in place of that dx, I'm going to write 1/2 du. So when I do that, I'm going to put this 1/2 out front before I take the antiderivative. So then I'm going to have u to the 1/2 du. Now I'm going to go to take the antiderivative. So here's that 1/2. U raised to the 1 more power, so that would be 3 halves, multiplied by the reciprocal, which would be 2/3, plus my constant. So then here, I'm going to have u to the 3 halves power divided by 3 plus c. And the very last thing I'm going to do is I'm going to go back and ask myself what to do equal. That was 2x plus 3. I'm going to have 2x plus 3 raised to 3 halves power divided by 3, add my constant, and this is what my function is equal to. So in this case, I had to adjust because my 2 was not part of the original equation. I was missing that. So I had to solve for dx, and that's why I substituted 1/2 du, that's dx. All right, let's try another one. So this one I have the antiderivative, and so I'm going to ask myself, what am I raising to the power? So I'm raising this. So I'm going to say u is equal to x squared plus 1, and then I'm going to find the derivative of that, which is going to be 2x dx. Then I'm going to sort of, I think of it as like shopping. So up here I have an x and I have a dx. So here's the x and the dx. So I need to take care of that too. So I'm going to solve for this x dx, and I'm going to make this 1/2 du is equal to x dx. Now I can just do a simple substitution of 1/2 du for this x and for this dx. So rewriting that in terms of u, I'm going to do u to the 1/2 power, that takes care of that square root, and then I'm going to have 1/2 du. I'm going to like that. So this 1/2 I'm going to bring out front, so 1/2. I'm going to add 1 to the power, so this will be 3 halves multiplied by the reciprocal. And add my c, the 2's will simplify, so I have u to the 3 halves divided by 3 plus c. Last step is substitute the x back in, so x was x squared plus 1, 3 halves. I'm going to do multiply by 1/3 divided by 3 up to u plus c, and this is going to equal f of x. And let's try another one. So this one, again, starting off with the same thing, I'm asking myself, u is equal to the 1 minus 3x squared power. So this u is what's being raised to the power, so that takes care of that. When I take du, I'm taking the derivative of that, which is going to be negative 6x dx. And so, shopping, I'm going to have x dx, so x dx. So when I go to right, so I'm going to make this negative 1/6 du equal to x dx. So I can substitute in that negative 1/6 for what's highlighted up there. So I'm going to have u is being raised to negative 2 power. I have that 8 there, from there. And then the du is going to be negative 1/6 du. Well, when I multiply, I'm going to say I'm going to multiply 8 times negative 1/6, and when I do that, I am going to get negative 4/3 to negative 2 du. Now I'm going to take the antiderivative, so here's that negative 4/3. I'm going to add 1 to negative 2, so I'm going to add 1, that'll be negative 1. And then divide by negative 1, multiply by negative 1, whatever makes you happy, and that's plus c. So this will end up being a negative, I'm going to start with the negative 4/3 times 1 over negative u, because that is being raised to negative practice in the denominator plus c. The negative times the negative will be positive, so I'm going to have 4 over 3. In place of that u, I'm going to write what it was equal to, which is 1 minus 3x squared plus c. And that's going to be equal to f of that. So I wonder if that's like too nice to actually turn them up. And that's the thing. All right, number 6. number 6, what am I raising to the power? I'm raising this 4x minus 1 to the power. So I say u will equal 4x minus 1. And I'm going to ask myself, what is the derivative of u? Well, I look up here, the derivative will just be 4dx. So when I go, I have this. So when I go to do the antiderivative, I know I'm going to have u to the 1/2 power. I can make dx equal 1/4 du. So this dx is going to equal 1/4 du. So I can take care of this. So it's 1/4 du. The problem is now is I have this leftover x. And I have to put everything in terms of u. So I have to figure out a way to write that x in terms of u. So looking at this that I have it to do that is I can look at this equation right here. And I can say to myself, can I solve for x based on that? And of course the answer is yes, so I'm going to do that. So I'm going to say u plus 1 equals 4x. So then I'm going to say u plus 1 divided by 4 is equal to x. So this is going to be like a new substitution. We've never had an extra variable before. So in place of this x, I'm going to write this u plus 1 over 4. So I'm going to put that in here. So u plus 1 over 4. So I am going to multiply the 1/4 times the 1/4. And I'm going to get 1/6. Then I'm going to have u plus 1, here that's for, times u to the 1/2 du. That's what this is going to equal. And before I take the antiderivative, I'm going to distribute this. I'm going to have 1/16, and then adding exponents, this will be u to the 3/2 plus u to the 1/2 du. Now I'm going to take the antiderivative. And at any time you can bring this 1/16 out if you want to. And just know that you're going to multiply your answer by 1/16. If I were substituting in numbers at this point, I would definitely get 1/16 out. So now I'm going to take the antiderivative. So I'm going to mix 1/16 here. Add 1, so this will be u to the 5/2 multiplied by the reciprocal to this. Okay, in this one, I'm going to highlight what's being raised to the power. So my u is going to be that 4x minus 1. So u is equal to 4x minus 1. And then du is going to equal 4 dx. So when I go to write this in terms of just u, I'm going to have u to the 1/3 power. And then dx is equal to 1/4 du. So 1/4 du, and that takes care of dx. So it takes care of dx. The problem is, for the first time ever, we've got this extra variable hanging out here. So I have this x, I have to take care of that x. And the directions are to write everything in terms of u. So I'm going to have to go back to this equation here, and because that's the only equation I have that relates u and x together, and I'm going to have to solve for x. So I'm going to say u plus 1 equals 4x. So u plus 1 divided by 4 is equal to x. So what I'm going to do then is I am going to put that where the x was. So I'm going to highlight that blue so you can later on you're looking at this, you understand where it came from. And that's going to go here. U plus 1 equals 4. So all these are being multiplied. And just so we're clear, this u to the 1/3 is based on this. This 1/4 du is based on this, the dx, which is here. And then finally, this part right here, the u plus 1 over 4 is what x is equal to, and that's here. So everything in my original antiderivative is accounted for. It's adjusted and it's written in terms of u. I need to clean that up a little bit because it's not very nice looking. So I'm going to say, I take 1/4 times 1/4, I get 1/16. And I have u plus 1 times u to the 1/3 du. Now I'm going to distribute to the 1/3. And you know what? We're going to add, I'm going to take this 1/16 out because I can always factor that out. So I'm going to have u to the 4/3 because I got exponent and multiply, plus u to the 1/3, and then I'm doing du. Now I'm good to go. I can take the antiderivative because I don't have anything except for something. So I'm going to add 1. Let's use that for multiplication. I'm going to add 1. So this would be u to the 7/3 multiplied by the reciprocal of 3/7. Plus, add 1 4/3 multiplied by the reciprocal of 3/4. Plus c. So, when I do this, I'm going to multiply that and then distribute this 1/16 back. I'm going to have 3 over 112 u to the 7/3 plus 3 over 64 u to the 4/3 plus c. And the last thing I'm going to do is substitute that 4x minus 1 back. So we're going to have 3 times 4x plus 1 to the 4x minus 1. So sorry. So 7/3 over 112. Plus 3 times 4x minus 1 is 64 plus c, and this is equal to f of x. Okay, moving on to the next one. So this one I'm doing new substitution, change to variable, follow the same process. There are 2 options to evaluate. So up and before, this was an indefinite variable because I didn't have an upper bound or a lower bound. I just split like that, and this is where I have plus c. Now I'm going to have a lower bound and an upper bound. The c part is going to go away because it's subtract out. I'm following the same steps I did before, but at the end I have a choice of how I'm going to solve it. So, give me 1 second. I'm going to start the procedure just like I did before. I'm going to ask myself what is being raised to the power, and what is being raised to the power is going to be that x squared minus 1. So I'm going to say u is equal to x squared minus 1. And I'm highlighting that in yellow because that's going to be my u. So if you want to sort of keep track as you go, you can. And now you have u to the 3rd power. I could do that like step by step if I wanted to. Some people like that, some people all two. Now when I take the derivative, I'm going to have 2x dx. So if I go up here and I look, I have x dx, I have the x, and I have the dx. So I'm going to leave this x dx on one side by itself and make this 1/2 du is equal to x dx. I know I'm not solving for dx, but I really don't have to. So I'm just going to, so in place of this x dx, I'm going to write 1/2 du. And then everything is taken care of. So now I'm doing 0 to 3. So I'm doing the same procedure I did before. I'm going to bring this 1/2 out front. 0 to 3, u to the 3rd, du. Now I'm going to take the antiderivative. So here's that 1/2. Raise u to the 4th power, divide by 4. And now I'm going to evaluate from 0 to 3. Here let's begin to have this thing x is equal to x is equal to x is equal to x is equal to. I should probably write this in red because this is really important. Because if I were to substitute 0 and 3 in right now, I would be way wrong, way wrong. Because that's based on x. This is in terms of x. So my lower bound when I'm using x is 0, my upper bound when I'm using x is 3. So right now I have a choice. I can say, well, I'm going to stick to what I know, and I'm going to say, okay, I'm going to rewrite this in terms of x. I'm going to have 1/2, and then this will be u, which we said was, what did we say for this? X squared plus 1, yeah, x squared minus 1. X squared minus 1, that's being raised to the 4th power over 4, and I'm going to evaluate that from 0 to 3. So I could do it that way, and then I would do 1/2 times 3 to the squared minus 1 to the 4th be, I think, U1. Maybe not. I'm looking at my paper. And I get 512. This is after distributing 1/2 minus 1/8. And that means I'm between 5, 11, and 8. I can do it that way. So what I did is I took the time to rewrite it in terms of x, and then substituting the x values for x is equal to 0, 6, and 3. The second way, and this is a big or, you're not going to do both ways. The second way is or. So I can go back up here and say, well, my lower bound was 0, so lower was when x is equal to 0, and so u would be 0 squared minus 1, so the lower bound would be -1. The upper bound is when x is equal to 3, so I would say u, in terms of u, that would be 3 squared minus 1, which would be 8. And then I can substitute right in here, so I'm going to so I can have u squared over 8, distributed at 1/2. And now I could do this from -1 to 8. And then I'm only, so I would have 8 to the 4th power over 8 minus -1 to the 4th power over 8. And when I do that, I'm still going to get 512 minus 1/8, which would be that 5, 11, 55. So either way you want to do it is fine. The big catch for like leaving in terms of u is you have to remember this step here when you're changing your upper and your lower bounds and rewriting that in terms of u. So I will do both ways, and then you get to choose. So I'll always do both ways. Okay, the next one, I have x times the cubed root of 1 minus x squared dx. So I'm going to start by saying that this 1 minus x squared is what's being raised to the power, so u is going to equal 1 minus x squared. So if I want to go here, that should be u to the 1/3 power. Always give yourself some room. This is 0. X is equal to 0. X is equal to 1. And I should start that right away because I have a different variable here, so I have to remind myself I'm not functioning in the same variable. So when I take du, I'm going to have -2x dx. So when I go up here, I have dx, and I have x. So I have x, and I have dx. So I'm going to have to say that divided by -1/2, so -1/2 du is equal to x dx. Now I can substitute in that -1/2 du for that x dx. So this is going to be -1/2 du. So if I pull that out in front, and then -1/2, and then this is from x is equal to 0, x is equal to 1, of u to the 1/3 du. That's all nice, clean, and pretty. So now I am going to take the antiderivative. U will be raised to the 4/3 power, multiplied by the reciprocal, which is 3/4. Times 1/2, -1/2. And I'm evaluating from x is equal to 0, x is equal to 1. Distributing it by -3/8 u to the 4/3, and evaluating from x is equal to 0, x is equal to 1. So choice number 1 is putting x back in for u, so this would be -3/8, and then 1 minus x squared from 0 to 1. Now I don't have to write x is equal to because I'm in terms of x. So when I do this, I would have -3/8, and then this would be 1 minus -1, or 1 squared, sorry, 1 squared. 1 squared. And when I do that, 1 minus 1 squared is 0. So that's going to be 0. Minus, and then I'm -3/8 times 1 minus 0 squared. That's going to be minus -3/8. That's plus 3/8. Or, big old or, I can leave it in terms of u and say my lower bound, let's start with lower. My lower bound is going to be, in terms of x, will be u is equal to 1 minus x squared. So u is equal to 1 minus my lower bound is 0, so 0 squared. So my lower bound is going to be 1. My upper bound is going to be u is equal to 1 minus 1 squared, which is going to be 0. Now here's where you might get a little confused. You've got to write it the way it is. My lower bound is 1, my upper bound is 0. And I wrote expectation. And I wrote it like this. My lower bound is 1, my upper bound is 0, and I'm doing negative 3/8 u to the 4/3. So following the pattern, it's, remember this is your, anyways, I'm doing upper minus lower, so I'm going to do like this f of 0 minus f of 1. So I'm putting in 0 first, negative 3/8 times 0 to the 4/3 power minus, and then negative 3/8 times 1 to the 4/3 power. So 0 minus negative 3/8 and then end up with positive 3/8. You could have done it that way, or you could have done it the opposite of 0 to 1, however you want to do it. Remember that you're doing upper and minor minus lower. So in this case, my upper bound is 0 and my lower bound is 1, so it's kind of going in the opposite direction. I hope that doesn't confuse you. Okay, the last little thing is about even and odd functions, which kind of makes sense. We talked about this negative a before. So if I have an even function is where it reflects over the y-axis, in other words, a parabola. That's a great one. So a parabola is an even function. So the left and the right side look the same. So if I'm going from negative a to a, and I'm trying to find an area underneath the curve, I have this area here, and I have this area here. So once I find this area here, I can just multiply it by 2 to have the area of the whole thing. So if it's an even function, then your antiderivative is going to be 2 times f of x from of a. 2 times that. So that should make sense because these two are going to match. If f is an odd function would be, say, something raised to the 3rd power, which would go something like this. If I'm finding the area under the curve, I'd have this and I'd have this. These numbers are going to be the same. One's going to be positive, one's going to be negative, whatever that number happens to be. I just put a 3 in there. So these two are going to, one's going to be negative, this will be a negative area, this will be a positive area. They're going to be the same area, so this is always going to equal 0 if there's an odd function. All right, I hope this helps, and I will see you next time in class.